assignment briefing session. You might think it's a bit strange that I'm briefing you on the assignment when you haven't actually done anything yet. But I think it's just important for you to have an awareness of what your submission will be. Okay? So that when you're sat in lectures, when you're practicing yourself, you know what you're aiming for. Okay, just want to just cover these, what I call polite lecture rules. Okay, just a few rules that I like to stick to just to make everything run better. And I'm sure you're fine with that. Try and be on time. No more than 5 minutes late, please. If you turn up and you're more than 5 minutes late, please don't come in. Okay, because it's quite disturbing when people are, you know, if people are coming in throughout the lecture. Okay, but remember, the lectures are all recorded, so, you know, if you're late, just don't come in, just watch the recording later. All right. Equally, I'll try not to be late. I had a bit of a technical problem there, which is why we've started a little bit late, but I try to stick to time, and I try to make sure that I keep the breaks just so that you have a chance to get a quick rest or a drink. All the lectures are recorded. Okay, so note taking, up to you. Please tell me if you can't hear. Please feel free to ask questions during the lecture. So I really don't mind if I'm busy talking. Just put your hand up and ask me if you want, and that's great. Really happy with that. You can ask me questions at the end of the lecture, but the thing just to remember is I need to have a break between lectures so I can get a drink and rest my voice. So try not to all come up at the end and ask me questions. What I will be doing is, in the following weeks, I'll organise some time slots where you can come and see me if you've got issues. You won't have any issues yet, but you'll find once you start using the software, you'll probably come across problems. And what I'll do is we'll have a system where you can just send me an email to arrange an appointment to see me. What I normally then ask you to do is just to re-watch the video and just make sure that it's something that you've not missed in the video. But otherwise, I'm happy to see you. But I find it works better if we can have an appointment in my office, sit and work through it. The problem is if you all bring me issues at the end of the third session, one, I'm exhausted, okay, because I've been talking for 3 hours, and often, you know, if you bring up a USB stick and say I can't get my Windows to work, it's not the best format for me stood here with the little screen. I'd rather do that in my office with a proper time slot. All right. If it's just a quick question, by all means come up and ask me. All right. I'll try during the lectures to at certain moments to ask you if you've got any questions. All right. And yeah, please no talking while I'm talking. I'm sure you understand that. Okay. So I'd just like to stick to these polite rules throughout the module. All right. Okay. Briefing document is available on Mole. Let's have a look at that straight away. So if we go into Mole, you might see on Mole, if you want to navigate back, you have got these controls at the top here. So I'm going to go back to the beginning, connect to the internet. Sorry about that. says it's connected. Okay, right. Okay. Back to the beginning, course content. If you go here to assignment details and resources, and have a look in that, then what you've got in here is a series of templates, and we're going to have a session covering InDesign. I think that's next week, so don't worry about these templates for now, but the templates are referred to in the briefing document. It's just a report template. Okay, let's go into the briefing document itself. Just quickly download that. I'll just open it off my hard drive for speed. Okay, so this is the assignment briefing document. The module handbook has a sort of brief summary of this, but this is the full details. Okay, let's just zoom in a bit there. So I'm going to explain the briefing document to you, and I'll explain the submission to you, and then we're going to look at some examples from previous years. And we'll finish at about 12 o'clock so that we can just have a quick break before the next session. What I should probably explain about this module is it's quite a condensed module. So we typically have 3 sessions a week, then you have to go away and practice, and your submission is, I think, just before Christmas from memory, or maybe just after Christmas. But we deliberately kind of pack the content early on, so that you can kind of have a good level of input, go away and practice. But it does mean it's quite intense. Okay, so the next 5-6 weeks on this module is quite hard work. It's quite a lot of work for your brain. Okay, but you'll see the benefits, I hope. Okay. So the assignment will allow the students to develop their simulation and analysis skills through a design project scenario. Sorry. The scenario will place the student in the role of an architect, I should probably say architect or engineer, developing a design in a hypothetical practice context. Model files will be provided as part of the scenario. You will be expected to develop the report during the module duration by applying and testing the skills learnt in the lectures and workshops in the design scenario. So just to summarize that, what we're doing is we're imagining that you're working in an office and you're a kind of simulation consultant. We're not asking you to design a building, we're giving you a building, and I'll give you the files. Okay, so it's imagine that you work in an office, or you're a sustainability consultant, and you're asked to input and help out with the design of a building. But there are some designs in place. So I'll give you those files. And then what you have to do through the assignment is, for the different aspects of simulation, you're expected to run simulation and consider the analysis, and then to try out some different design options on that building. It will be much clearer when you see the examples in a few minutes, okay? But I thought that's a much better way of doing it than setting you specific tasks and, week by week asking you to do a specific simulation. You have much more control over it this way. Okay, so the assignment is primarily about simulation and analysis, and it is therefore not required for you to produce a building design. You will take the role of a design team member, advising other architects and consultants on design decisions through simulation and analysis. You will be given a site, a project brief, and designs previously prepared at various stages of detail. So the files you will be given will be at different stages in the design process, from kind of early stage design through to a more detailed building design. In alignment with the module lectures and learning outcomes, you will be asked to conduct various types of simulation and analysis, and to formalise your conclusions and advice into a design report document. The reason for providing a project scenario and initial designs is to allow you to quickly move into a phase of simulation and analysis, rather than spending a large amount of time in site selection and design. The scenario also simulates a very real position in practice whereby an architect or consultant is working as part of a team and advising on issues of environmental performance and sustainability. So I don't want you to spend weeks and weeks modelling a building, because that's not what this module is about. We need you to get into the simulation quickly. Okay, project brief. And it's a kind of a real brief, in a way. As part of a wider university campus master plan, currently being carried out by Field & Clegg Bradley Architects, there is a proposal to remove the vehicles from the Arts Tower forecourt, down there, and to return the forecourt to its original intention as a plaza or landscape area. The proposal will also have a cafe serving the plaza with additional university accommodation above. It is expected that this building will be low-rise, 2 to 3 stories, so as to not adversely affect the setting of the listed Arts Tower building. The brief is not yet fully developed, and the exact accommodation is part of the ongoing design process. However, it is expected the accommodation will comprise of, and I'm not going to read through all of this, but there's a brief for what the building is, okay, in terms of rooms, room sizes. You can read that all yourself. And there are some ideas about areas. And those room sizes are reflected in the building model that you'll be given. Tasks. You are required to conduct a series of simulation and analysis tasks, and to advise on the performance of the current design and make suggestions to improve it. All results must be formatted into a single report. You will be provided with a standard report template, and you should use this with minor modifications as required. So we're giving you a template. Imagine you're working in a practice. No one's going to ask you to invent a graphic style and, you know, oh, I think I'll have big text and blue text and I'll use that fancy font that I saw the other day. In a practice, you'd be given a practice template. I'm going to give you a template, okay? I don't want anybody to sit and waste time thinking about font styles and sizes, because that's not important, okay? The template I'll give you is fairly simple. Okay, the tasks relate to the lecture series, with most lectures having a related task. The outcomes from the tasks and your design suggestions should be related to each other in the report to form a cohesive set of analysis and proposals. Generally, each task will be presented on a series of separate sheets within the report, normally 2 to 4 pages per task, but it is up to you. Okay, this is important. Although the report submission is not until after the lecture series is completed, you are advised to complete each task soon after the lectures, rather than leaving them all to the end. This way, the content will be fresh in your mind from the lectures, and you will build up the report week by week. So that's really important. So let's say we have a week and we're doing daylight analysis, and I'm showing you that here. I encourage you to then, in your own time, complete the daylight analysis section of the submission of the report. Do it that week. Do it while it's fresh in your mind, while you're learning the software. Don't leave everything to the week before the submission. Okay? Some students have done that in the past, and they were not very happy, I can tell you, okay? Because they got to the end, they thought, oh yeah, I know all of this, and then they said, I can't remember, oh dear, I can't remember how we did that. And then they found, oh no, that I couldn't get that to work, that model, so I better email Aidan really quickly and say, Aidan, the submission is due tomorrow, but I can't get my sun path to work. Okay? Don't do that. Build it up as you go along. That way, you'll enjoy it more. It gives you a platform to learn the skills. Okay? There's no point, if I show you some software skills here, you need something to practice them on. And this gives you that vehicle to practice. It gives you a reason to practice what I'm showing you. This module is not delivered in a kind of traditional manner whereby we don't deliver it with you all sat on computers and you know, me saying, right, everybody needs to make a window, and then you all have a go and I walk around and check on you. I don't deliver it like that. I don't think that's a good way of learning software. Okay? I demonstrate, and then you need to go away and practice and make mistakes, and get things wrong, and fix them, and go online. I'll show you some resources, and find out problems with shading devices in Revit, find out all those issues. Okay? There's a worldwide community of Revit users, so whilst I'm here to help you, you don't need to rely on me either. Okay? There's lots of people out there, lots of online help. I'll show you those later. So that's really important. Okay, I'm not going to go through each of these sections because I want to show you some of the examples. But what you'll see is that the different sections, site and context modeling, site wind flow analysis, solar analysis and design, these are the sections in your report, and they're exactly the same as the lectures that I give here. So generally, for each series of lectures here, you need to complete 2 to 4 pages in the report. And I'll show you those examples in a moment. Okay, so you've got incident solar radiation, energy analysis at a conceptual level, and a building model, daylight simulation and visualization, integrated shading, simulation and analysis conclusions. Okay. Submission details are in the handbook. It's a digital submission to mole. All right. So have a good look at that. There's lots more information there. But what I want to do now is, in the time we've got left, is show you some of the examples from previous years. Okay, just bear with me here. So if you go under the assignment details and resources, you can ignore the Revit. There are some Revit files in there, but just ignore those for now. But have a look at the example submissions this week. Go in there. You've got what, 6 submissions from 2 years ago. Start with the submissions from last year. And I've put about, I think, 6 or 8 submissions on there. I'll just start with one here. And these are all good reports. So I'm not going to give you the grades, but these are all sort of good A or B level submissions. So it gives you an indication of what the kind of standard we're aiming for is. And they're probably going to take quite a while to download, so I'll just pull them off my hard drive instead. Just bear with me a second. So if we start with this one, we're on there, the Arts Tower. So the first thing is just to note the template. This little footer at the bottom, the title, that's all given to you in the template. I mean, you can change it if you want, but you know, there's not a lot of point. So we've got a little introduction here, a sort of contents index to what's in the report there. Then moving into site and context modelling. So you'll be given an incomplete site model, and you have to finish it off. Okay, so and what some of the students do is just start again from scratch, because it just gives you the opportunity to practice. So the student here is showing how, starting from a map and from aerial photographs, they built up, they developed a site model, and I thought this was quite good as well. They're actually just showing us some of the tools that they've used in Revit to do this. And so here's the site model that they started to build. And you know, here this is really important that you start this early on. Some of the best work, the students built really good site models, quite detailed, which meant that later on, when they're doing a visualization, you've got really good quality background in those images. So, you know, make a good model, and that will help you to practice the skills. So here's the student's model that they've built, and I'll just zoom in a bit. They were using some of the rendering facilities in Revit to get some good quality renders. Now, they didn't learn those skills until later on, so I know what this student actually did was they built the model now, and they came back in later on to do some of these renderings. But at this stage, it's just a sort of empty site model. But it's, you know, modeled to a good quality of detail. Okay, wind flow analysis was next. So here you see the student is simulating the wind around the site and analysing the results, talking about the results. And this is really important. The best work is the work where there's simulation and analysis. Simulation without analysis is not much use to anybody. If all you do is the simulation, and you provide that, but you're not analysing the results and explaining the consequences of the results, it's not a lot of use. And that's why the module is called Simulation and Analysis. Okay, now what the student's doing here, what they've done now is they've put the new building on site. So this is the new building. And again, you'll be given this file. And they're now simulating the effect of the wind on that site with the new building, and considering the consequences of putting that new building on. And they are trying with the wind in different directions. Okay, next section, site, solar analysis and design. So what we've got now is a series of simulations looking at the shadow pattern on the site. Okay, quite simple. And then over here we've got, this is actually an overlay where they've overlaid a number of shadows on top of each other. Okay. And then a different view here, looking at those shadows in relation to the building. So the green is the new building, overlaying multiple shadow paths to consider the effect of the new building, and is that building getting good solar access, or is it sat in a shadow? Really useful. Quite simple to do, but really useful. Okay, moving on to solar radiation. Here we've got the simulation of the solar radiation on existing buildings, and then a really nice image here where this was just done in Photoshop, but overlaying that onto an aerial photograph of the real site. And again, there's analysis. So there's a little bit of commentary about the work that's been done. Still instant solar radiation now, but looking in more detail. So looking at the actual figures on the, and this time on the proposed building. So that's the proposed building, and that's the early stage design you're given. And as you can see, it's just a block. It's just a 3-story block. There's no detail to it. So analysing the solar radiation, and then in this report, the student then was interested in using photovoltaics. So they simulated the amount of energy that photovoltaics could achieve on that site. And in fact, they did the same for the library. So that's where the report is moving just from analysis into starting to make some suggestions. Energy analysis at a conceptual level. So if I just zoom in here, what we've got is the student trying out some different shapes of the building. So trying out a 3-story block, this configuration with a slightly strange angle on it, not quite sure why. Trying a longer building but lower. Trying a higher building but with a more compact footprint. And very quickly looking at the energy performance and the carbon dioxide emissions of these different options. And you can see that there are variations. 52 tonnes per year of carbon, 55, 46, 45. So beginning to get some kind of results of a very, very early stage design. Excuse me. You could imagine you could produce these designs in a few hours, very quick. Okay. Let's just go back to that. And then, once the student had decided on that shape of the building, they then repeated the process, but this time changing the position of the building and seeing if that different position will improve the energy performance. And then there's a conclusion. So really important to analyse the results. Now, moving into energy analysis of a more detailed building. So this is the sample building file. And here they are comparing, I see what the differences are. So here, the student's comparing this design which is fully glazed at ground floor, and then they're comparing that with a design which has less glazed area, and looking at the implications. And as you can see, the top building, metric tons of CO2 per year, 35. The bottom, 29. So reasonable level of confidence that option here probably will perform better. Then another comparison. No, this is the same comparison, but just looking at some slightly different data. So looking at the cooling loads and the heating loads throughout the year for those buildings, which would allow you to analyse in slightly more detail why is one building performing better than the other, and you could actually, look closely at that and see that it's probably to do with the cooling load from those windows. Daylight simulation and visualization. The thing to remember is this is an A3 size report, so although some of these images look a bit small, at an A3 size with high resolution, they're fine. So what we've got now is the student taking one of those spaces in the building. We only ask you to look at one of them and start to investigate that room in terms of daylight, in terms of views, in terms of shading. So here, starting just with an initial visualization of the room to get a feel for what it's like. Then moving into daylight factor analysis and doing that both in a plan view here and in a three-dimensional view. And I'm going to explain daylight factor to you when we get to that session. And then also looking at illuminance, so looking at direct sunshine for the same space. I think this student actually, they decided to simulate a number of rooms, but I don't think you necessarily need to. Then, moving on from that, starting from that base design, investigating the impact of shading. So, from that initial study, the student identified that there was just too much light in that space. It was very, very bright. With lots of brightness from the light, you bring heat, which contributes to overheating. So they've decided that they think it needs some shading. And they're investigating a few different types of shading. You probably just make out the difference here, that there's a sort of dense shading device here, whereas here it's much more open. Just zoom back out again there. And a really good investigation here, comparing the impacts of those different types of shading. And that's both in terms of kind of quality, but also in terms of quantity, the actual metrics of daylight. Then, in this instance, the student repeated that for the other rooms. Sorry, the other rooms in the building. You can actually see it now. Okay, so that's page 19 in the report. So it must be almost finished. Yeah, and here is the overall conclusion page. So this is the student summarising the results of the study onto a single page with some images from the report. Yeah, and some references. So that's an example of a good quality report, well presented, good simulation, and some analysis. Also, I mean, it's limited to 20 pages, so it's not a huge amount of work. There's not a huge amount of writing here. You know, we're not looking for thousands of words. Just a short bit of analysis on each page. Okay, I'm going to look at a different example now. Let's try this one. Okay, so different one here, different report. Introducing the site, great. Contents page, good. Really good site model here. I mean, the important thing when I talk about site modelling, I will explain this further, but there's always a balance between modelling what is adequate for simulation and modelling something well enough for visualisation. Okay, we've got wind simulation, as we saw before. Okay, again we've got solar analysis on the site, different times of the year, and some good analysis here where the students kind of zoomed in to just to explain that here's the building, that they're not overly concerned about the shadow onto that building. solar radiation, and again we've got the kind of the colour-coded view and a more detailed point view. Okay. Again, conceptual energy analysis. So trying out a few different shapes here, looking at the performance. Again, a few more shapes here. In fact, in this example, trying 5 different shapes. Moving into the building level, and what this student has decided to do is to compare 2 identical building shapes, but to change the heating system in the different buildings, and to see what impact that has on the energy consumption. Then moving into daylight and shading. Again, we've got an internal visualization, and what I ask you to do is you have to complete the model. So the model that you're given is very empty in terms of furniture, and what you'll find when you do it yourself, as soon as you start putting good quality furniture in, it becomes a much more convincing visualization, and that's what this student's done here. So as before, we've got visualization, we've got daylight factor analysis, starting to understand that space. Also here, looking at the direct sunshine in that space, in a plan view. And I think this is without shading, looking at some different rooms. I mean, you start to see here the benefit, because the site context is modelled in reasonable detail. When you get a view that looks out the window, you've got a background. If you don't have enough site model, it can kind of look like you're in the middle of the ocean, because there's nothing outside the window. Okay, good use of some plans here. And then here, looking at some different shading devices. Okay, I think what this report, oh no, there we are. And then moving into conclusions. So concluding the results and making recommendations for this building. Okay, we'll look at one more and then we'll have a break. Okay, last one. And this student, again, using the template. So all of this, the numbering, the title, the text, is all given in the template. And in fact, this is the correct use of the template. The text is quite small, deliberately, because it's an A3 document. What some of the students did is they made the mistake of, they were viewing it on screen, and they thought that text is too small, so they made the text larger, but they forgot that it's actually an A3 report. And so small text is perfectly okay. Okay, so site and context modeling, and some really lovely kind of screenshots here from Revit, which is great. Just showing the process of building up that model. That's a kind of basic render from Revit, and then later on they did this very good this cloud rendering using the Autodesk Cloud. And I think this is a really great example, actually, of a site model which it's got a good level of detail without kind of putting too much detail in. And the benefit, I suppose, of modelling to this level of detail is just that it looks very realistic. The downside is that it adds weight to your file. Your files get bigger and heavier. So there's a balance to be had. But I know in this case, the student was really pleased to be able to develop a model to this level of detail, which they'd never done before. So there's the model that they've done. Quite good here is that they've deliberately cropped it, and I'll show you this technique in Revit of how to just crop your model. Moving into wind analysis. So here we've got a really good section through the model showing the impact of the wind, and then using the different visualization types, we've got different types of wind flow analysis. Now, unfortunately, last year there was a Revit wind flow plugin, and you could do wind flow simulation in Revit. They've got rid of it now, and unfortunately you can't access that anymore, which is a bit of a shame. So we'll do wind simulation in Autodesk Flow Design, which is a standalone package. I'm not quite sure why they've done that, because it worked quite well as it was. But anyway, more wind flow analysis there. And then moving into solar analysis. And different, I think quite interesting here, different kinds of analysis. So here the student is kind of studying this and indicating 50% shadows, 5% shadows, just giving us that level of understanding. And here a good image overlaying all of those shadows, overlaying it without the proposed building and with the proposed building. Okay. Solar radiation analysis, as we've seen before, very useful. In this case, looking at the roofs separate from the walls. And I think they were interested in potentially putting photovoltaics on some of these other buildings. A more detailed solar analysis, and again, considering the possibility of putting photovoltaics on the roof. Conceptual building, 4-story, 3-story, comparing those. Then comparing different shapes, different forms. Moving into the building, so starting here with the baseline building, so no modifications, and then starting to make some changes. So they've changed the overhang here, analysing the results. Moving into daylight, again, taking a room, populating it, visualising the space, and then simulating the results. Sorry. And then repeating that. I mean, a lot of these techniques, once you've learned them, they're very quick, and you can do lots of this quite quickly. So, trying different shading devices here. You see the different kinds of shading that's been tried there, and again a different shading technique here. And then repeating that in a different space. Okay. And conclusions. So again, another really good report. The report is 20 pages. You don't have to include your contents page or your bibliography in that. Okay, we'll stop there. Any questions? Yes.
And is the street of the building having to design the street?
No, you're given the building. So you're given the building as a conceptual model and as a detailed model. You don't have to change it, you might choose to modify it. So, for example, the previous student changed the windows, but you're not expected to make substantial changes to the building shape. Okay? But the building you're given is quite empty. So in order to make the interior visualizations, you can put furniture in. I'll explain that, and I'll provide you with some furniture files as well. All right.